vector differentiation. In vector differentiation, we have first topic, gradient. Hello, is whiteboard visible to you?
Yeah, ma'am.
All right. So vector differentiation. Operator. We say this del.
Is that the sign of that?
Yep.
Okay.
This del or nil. Usually we say del. Okay.
Okay. Okay.
And what it and defined as once again. I'm just controlling the background noise. Just give me
Okay.
a second. So del is defined as del is equal to del over del x into I cap plus del over del y into j cap plus del over del z into j cap. How can we use? Let us learn. Let phi function of x, y, z is a scalar function, we can say. Then how we can find gradient of phi? then gradient of phi is we can define as we use this symbol. Either we can write as or del phi. What it means by del phi? Let us learn. Del, as we know, del over del
Yeah.
x into I cap plus del over del y into j cap plus del over del z into k cap. And phi, the scalar function of x, y, z. So we can write it as we will do one example to understand this well. You have examples or shall I use my own?
Ma'am, can you please use your own example?
Uh, you want, if you want from your like PDF, then I can use. What do you say? You have in your PDF which you have sent me?
Actually, I'd send you the 6 PDF, I think so. In
Okay,
that,
okay,
any some.
okay. All right. So we will partially differentiate it, this function, okay, as
Okay.
del phi over del x y cap plus del phi over del y into j cap plus del phi over del z into k cap. Like terms involving x will be here. Other terms obviously will be zero, as you know, in partial differentiation,
Okay.
right? Terms
Yeah.
involving y will differentiate here, and other term will be zero.
Okay.
And similarly, here will be of z. So we can write them as also like here we are differentiating this phi with respect to x, so we can use this symbol also. This symbol represent we are differentiating phi with respect to x.
Okay.
And here we are differentiating phi with respect to z. These are various symbols. Either we can write as or can use. Here we are differentiating along with terms, and these terms can be written as phi z into k. Got it? This is
Yes.
formula. You can see gradient.
This formula is for grad.
Yes, gradient of phi we can write as also.
Okay.
This is formula. Okay. We will do one example. I'm taking your from your PDF. I'm just checking. Okay. You have this question. See. Question is find gradient of phi at P, at point P, they have given to us. If phi is equal to x into y square plus y into z cube, and P is 1, comma minus 1, comma 1. Okay, we have this point. So now let us find gradient of phi at point P. First of all, we will find gradient, then we'll put this value. Okay,
Okay.
so gradient of phi, we can use this formula del over del x into I cap plus del over del y into j cap plus del over del z into k cap. And phi is x into y square plus y into z cube. Del over del x, and we are differentiating x into y square plus y into z cube. Even this will be 0, but we are writing first into I cap plus del over del y of x y square plus y into z cube plus. Are you getting me?
Yes,
Del
ma'am.
over del z.
Ma'am, like here should like J should become
Yep,
okay. Yeah.
j cap. Yes. And x into y square plus y into z cube into k cap. So we will have here y square into I cap. Got?
No, ma'am.
See, we are differentiating with respect to x. So this term will be 0 in partial
Yeah, yeah.
differentiation. So
Yeah.
x will be 1. So we will take y square. You got now?
Yeah, yeah, yeah. Sorry for that.
It's okay. Plus. Here we will have 2xy because x is constant and
Yeah.
differentiation of y square will be 2y. So we will have
And
2xy and plus z cube because y will be 1.
yeah.
Got it?
Yeah,
Into
ma'am.
z cap. And here we will have
Or 0 plus
z square. Got?
yeah. Yeah.
Into k cap. This is gradient of phi. But we know we need to find at this point. Point means this is value of x, this is value of y, and this is value of z. You got?
Yeah. Yeah. So we should put that value in this
Yes.
XYZ.
Yes. Exactly.
Okay, means there will be a 1 minus 1 square.
Yes.
And then what about that J cap and K cap and I cap?
These are like unit vector, you remember?
What, ma'am?
Because del is vector quantity. You know,
Del is vector.
see this del, because this is the vector differentiation operator.
Okay.
Remember? So we involve these unit vectors, I, j, k.
Okay.
You remember or not? If you
Yeah, ma'am.
don't
Yeah.
remember, then I can explain you, okay?
Yeah, ma'am.
You want explanation?
Uh, yeah, ma'am. Just that answer. How? I would want to check that answer is correct or not.
Sure, sure, sure. You'll get answer in vector form. Yes. So
Yeah.
y is here minus 1
Hmm?
into I cap plus 2x is 1 and y is minus 1 and z is also 1. So what?
One only.
1q is also 1. You can take directly 1 also.
Yeah,
So
that
k
only.
cap plus 3 and y is minus 1 and z is 1. So 1 is square and you can take directly 1 also. So this will be I cap plus and here you will have minus 2 and plus 1. So minus 1 you will have, right? So
Yeah.
minus j cap you have. And here also we have minus 3 k cap. So we will get a gradient of a scalar in vector form. Okay? Because
Oh,
we are using vector differential operator to find gradient. That is why this is vector. And you want to know what it means? Now you remember these I cap, j cap, and k cap unit
yeah,
vector.
ma'am. Yeah, actually, I don't revise that. That's all. That also I can't remember it.
It's okay. See, when I'm telling you, okay. So along x-axis we take I cap, along y-axis we take j cap unit vectors, and sorry, along z-axis we take k cap. Like we measure vector in terms of unit vectors. Okay,
Yeah. Yeah.
like I means we have one unit along x-axis, and minus j it means negative direction is here. Okay,
Hmm.
sorry, here we take in negative direction of and take 3 units of opposite direction of k. See here. Are you getting me?
Yes, ma'am.
Yeah. So if we represent this, so we take just opposite direction of y here and z here. Okay. Then
Okay.
take values accordingly. 1 unit on I and 1 unit opposite direction of y,
Mhm.
and here also we take. Okay, then we can represent. Now you got, or you want more explanation?
No, ma'am, I got it.
Okay.
Ma'am, can we try and hard some?
Hmm?
Can we try and hard some more hard than this?
Sure, sure. I'm just checking in yours.
Or this one is only hard or moderate level or easy one?
They'll give you like sums, okay? Because to find gradient, they can give you like uh, having many terms involving x, y, z only.
Okay.
Okay?
Okay.
Like you
Like,
need to, yeah, they'll give you accordingly scalar function. Then you need to just differentiate to find gradient.
okay.
Not much hard here. Like we can have like in a fractional form also.
Okay. Then that will be a more hard for me.
Yeah, like they can give you like this. I'm telling you example, like they can give you like x, y, z like this plus something here like this. Okay.
Okay.
But obviously we will have terms involving x, y, z, either in product form or in quotient form. Yes. You got?
Yeah, ma'am. Can we try this?
Pardon? This one?
Yeah. Yeah, like
Yes. Yes, we can.
okay.
I have taken this random example, okay?
Yeah.
So find gradient of phi. So let us find del over del x y cap plus del over del y into j cap del over del z into j cap. And we have x, y over z plus 2 x square into y plus z square over xy. Del over del x xy over z plus 2x square into y plus z square xy into I cap plus del over del y. We take here phi, just xy over z plus 2x square into y plus z square upon xy to j cap plus del over del z of x into y over z plus 2x square into y plus z square over xy into k cap. So in first term, see, we have y over z only because x will be 1. So we have here y over z, okay? And
Okay.
here we will have 4xy. You got?
Yes, ma'am.
And here we will have z square over
Bye.
x square into y. You got this step?
Yeah, ma'am.
All right. Into I cap.
X plus.
Del over del y.
Yeah.
So here we, sorry, we will take result. So
Okay.
here we have
X
x over
upon
z.
X upon Z
Yes.
plus 2x square. Hello?
One second. Um, yes.
Plus 2x square plus Z square upon x y square. Is that right?
Yeah. One second. No? I'm writing. Just 2x square. Yes. And
Plus
yes.
Z square upon xy square.
Z square into x, y square into j cap plus. Here we will have minus x y over z square. And this will be 0 because,
Yeah.
and here we will have 2z over xy into k cap. This is gradient of phi.
Yeah.
Got it?
Yeah, ma'am. Thanks.
So is this enough for demo for today?
Yeah. Thank you so much for the demo. I just want to ask that suppose My friend would like to like they are interested, but they can't understand well English like me. They are comfortable in Hindi only.
Okay, okay, okay. I can teach you in Hindi also. Okay, not to worry.
So they will merge with me. Then I just want to ask that what will the cost of an fee or something like that? Like per head 2000. Like means first we
So
were
one friend or more?
one two will be there.
Okay, okay. So just tell me one or two, and I'll tell you accordingly. Okay.
Okay, thank you so much, ma'am.
Okay.